Hi there, I am Zachary Hoppock in Calculus 1 with Professor Ray. I am a part of Weekends 11, the group for weekend meetings, and I'm going to be going over my process, my work on solving these two problems. I want to start off by saying that in these two problems, both of them are indefinite integrals. So that way I don't, all I'm doing is solving for the antiderivative of x, not antiderivative of a set interval. So on the first one, we have integral sine of cosine of sine x times sine of sine x times cosine x times dx. What I did here is I wanted to use substitution, and what I substituted was sine x, which would replace both of these. I made u equals to sine x, and in order to get something to replace dx in substitution, I took the derivative of sine x, which is cosine, so I made it du equals cosine dx, and I divided both sides by cosine x, so that way dx equals du divided by cosine x. That way we now get integral sine of cosine u times sine u times cosine x times du over cosine x. And the cosine x will cancel each other out, leaving everything else to be u. So you have integral sine of cosine u times sine u times du. And I'll show this in my check in a moment. I did a backwards chain rule, because if you take the derivative of cosine u outside of this function right here, you get negative sine u. So, and if you do cosine, the antiderivative of sine is cosine, so you get cosine of cosine u, and I'll explain in just a moment. And then you add the c, add a constant, and you substitute back in what u is. It was sine x. So my answer here is cosine of sine x plus c. And I went ahead and checked. I took the derivative of this again, and as I said up here, I did a reverse chain rule. I'll probably have to do it a different way, because it probably would take a lot of explaining to do. But when I do the check, you have to do a chain rule, because you have cosine of sine x as an inner function of cosine of it. So derivative of cosine equals negative sine, and you keep the function inside. Then you take the derivative of that function, so you take the derivative of cosine of sine x, which would mean you have to do another chain rule, which gives you negative sine of sine x times derivative of sine x. And also, I forgot to mention here, the c, when you do take derivative of a constant, it makes it 0. Pardon me. And therefore, the next step, you have two negatives that are multiplying each other, so you can cancel them out. So everything will become positive. You have sine of cosine of sine x over here, goes right here, and then you have sine of sine x, which goes right here. And then when you take the derivative of sine, you have cosine x, and this matches this up here. So that's my check on A. And now if I go to part B, you have integral of 3 to the power of t all times dt. That is very easy. That is one of the exponential rules, which is integral of a to the x power times dx equals a to the power x divided by ln a, all plus c. So my answer here is 3 to the power t, all over ln 3, all plus c. And I rewrote it. Oh, I rewrote it like this as well. 1 over ln3 because that's a constant. Because I want to make sure that's been made aware when I do my check. And which is over here. You take the derivative of this. And what you get here is you have 1 over ln3, which is just a constant. So nothing happens to it. When you take the derivative of a constant to a variable power, I wrote it over here. You get the constant to the variable power all times the natural log of the constant. So right here, I made it go to 1 over ln3 times 3 to the power t times ln3 plus 0 because c becomes 0 because it's constant by itself. And now you have an ln3 on the bottom and an ln3 on top. So you can cancel those out, and all you're left is with 3t, which is what you have up here. And those are my processes, and those are my answers, and thank you very much.